Alright, I woke up early for this one, but this is probably going to be the longest study guide I've made because it's the last math guide for grade 10. It's the Term 3 ETA guide covering statistics, circles, coordinate geometry. So let's begin with statistics. So there's 4 measures of position, or actually 3, which divide a group into either 100, 10, 4, or 2 parts. We got percentiles, deciles, quartiles, and median. However, since these are actually just boundaries, we only have... So since it divides 100 parts, right? Therefore, there's only until 99 percentiles, there's only 9 deciles, and 3 quartiles. So the formula for all of them is basically this, but this one's for percentile. You basically just have to substitute the 100 to 10 and 4, depending on what are you looking for. So it's P of k is equal to k times n plus 1 over 100, and then the TH score. So remember that the number you get over here is not the actual value we'll look for the data. That's just a position. So if you get an integer, it's good. You can just count like 1, 2, like first, second, third or fourth, something like that. But if it's not an integer, let's say 3.7, you need to get the average between the third and fourth data. So let's try this one. So first one, we have consider this data set of 19 students. Consider this data set of 19 students and find the 15th percentile of the data. So first, let's try to solve for number 1. So number 1, I have to make it very small here. Here, I think we can do it here. Solution for number 1 and number 2. So first, we need to do the this one. P of 15 is equal to 15 and then 19 plus 1 over 100. Okay, and then when you put that when you put this part into the calculator, this one, you get 15 times 20 over 100, which is the third score. And then the third score is... Oh, wait, let's adjust it. The third score is... 1, 2, 3. So it's 32. So this is the answer for number 1 and 2. Okay, so that's a case where it's an integer. But what if it's not an integer? So let's try something a bit more strange. Let's try P of 73. So number 3, number 4. So we're going to put again P of 73 is equal to 73 19 plus 1 all over 100 TH score. So let's try to put that in the calculator. That equates to 73 times 20 over 100. So as you could see, this results in 14.6. So since we get 14.6 here, get the average of 14th and 15th. So in this the case, if that's the case, we go to this is 10, 11, 12, 13, 14, and 15. So it's this one. So the average of 41 and 42 is 41.5. And that's the answer for numbers 3 and 4. The position is 14.6, or the average between 14 and 15, and then it's 41.5. Okay, let's try to now exercise. A little bit of an exercise here. Let's try to count the data. So, let's see. You can count it. I'll give you a few seconds. It is... Okay, we don't even know in the answer key, so we need to manually count it. So this is 5, this is 10, 15, 20, 25, 30, 35, 40, 45. Okay, we have 50 data. So since we now know that 50, we can find the value of P5. So just like the same thing again, we have to do P of 5 is equal to 5 times 50, because that's our n, plus 1 over 100. This equates to 5 times 51 over 100, or the 2.55 fifth score, which is the average between the 2 and 3, so 23 and 27, which means P of 5 is equal to 25. And that's the answer for this one. Next, number 6. So find the median. There's two ways to do this. You can either find 50th, you can either find the 25th and 26th position, or you could just use P of 50. So let's just do it easier, since we know it's 25th and 26th. So therefore 50 plus 53. 50 plus 53 over 2 is equal to 51.5, and that's our answer. Alright, let's keep practicing. Okay, so number 7. A survey was taken to determine the average weight rounded off in kilograms of people ages 5 to 25 in Barangay Salawag. The data gathered represents the respondents below. Okay, we need to solve for some things here. So for number 7, it's median again. So let's try to use a different solution now. Let's try to use the P of 50 solution, because P of 50 is the median. So P of 50 is equal to, we have 50 data here, right? 50 data, okay. 50 times 50 plus 1 all over the 100. So like I said here, it's the 25th and 26th, so you should get something along the lines between that. So if we simplify this, we get 50 times 51 over 100, which is 25.5. So just like I calculated in number 6, so 25th score, which means we need to find the average between the 25th and 26th score, which is 63 and 68. So that's the average of 63 and 68, which is 65.5. Then next, number 8. Number 8, we have find the median, find the 75th percentile. So P of 75, or you can actually also do Q3, because that's equal. is equal to 75 50 plus 1 all over 100th score. So if we do 75 times 51 over 100, we get 38.25. So we must find the value of between the 38 and 39 score, which is this one. So we need to average 80 and 83. Which is 81.5. So there we go. Next, number 9 is interpretation. So median, you can treat it as like the midpoint of the data. So this is where the cutoff between the upper half and lower half. And P of 75 means 75% on or below. So 75% on or below, it refers to like 75% of the data is either on this specific one or below it. 25% of it is above. Okay, that's basically it. Alright, number 10. Another one we need to, another simple formula we need to learn is the percentile rank. So it's equal to the number of values below the score and the total amount of values. So, okay. So this is strictly below the score. So if it's equal, we don't count it, only below. So we have 30 items here, and let's say we need a score percentile rank of 48. So there's 26 below them, and as I said, 30 above them. Uh, 30 above them. So we just need to times it by 100. And that's equal to 86 point this number. Okay. Now the thing is, alright, percentile ranks are strictly from 1 to 99, which means even if you get 86.0001, you still have to consider that as 87. So this is 87th percentile rank. So this is a very simple one, so no need to do another example. Alright, the same, like I said a while ago, the same formula to find the decile and quartile of a certain position is basically the same. You just have to switch the denominator from 10 for the decile and 4 for quartile. So since this gets less precise, I'll only use one example. So in this case, a quiz has 20 items. The following are scores of 30 students. What score is at the 7th decile? So we need to do D of 7. So we need to do here D of 7 is equal to 7 times, we have 30 plus 1 over 10 TH score, which will simplify to 7 times 30 plus 1 over 10. That equals to the 21.7th. So we need to find the average between, I think this is 16, right? 5, 10, 15, 16, 20, 21, and 22. Yes, 16 and 17 are 21 and 22. So it's 16.5. So that is going to be our answer for the the 7th decile. Now, there's also another term called the interquartile range. It's Q3 minus Q1. So what the interquartile range does, it basically excludes all of the extremes. So like the extreme values in quartile, in like the first quarter and the fourth quarter in the data. So the bottom and top 25%. So this gives us like a reasonable range, you know. So let's try to solve that. We first need to solve for Q3 and Q1, which can be done with a pretty similar formula. So number 12 first. Okay. Q3 is equal to 3. This is 50, right? Yeah, 50. 50 plus 1 all over 4 score. So in order to put that in the calculator, we need to do 3 times 50, 51 over 4, which results in 38.25, which means we need to find the 38th and 39th average, okay? So it's going to be 351 and 354, which means when you add them up, 351 plus 354, then divide that by 2, you get Q3 is equal to 352.5. Same thing goes with number 13. So Q1 is equal to 1 times 50 plus 1 over 4, and that equals TH score, which equals to the 50, which equals to Q of 1 is equal to 12.75 TH score, which means we need to find the average of the 12th and 13th data, which 279 plus 282 divided by 2, that's equal to 280.5. So there we go. Now number 14, to solve the interquartile range, we need to just we substitute Q3 minus Q1. So we have 352.5 minus 280.5 is equal to the IQR. Therefore, our IQR is equal to 72, which means 50% of the data set has a spread of 72 points. Okay, all right, let's see. Go back to layer 1 to check. So we illustrated the following measures of position, all of them, because we used them. So we calculated also the specified, such as the measure of position of data. We interpreted it in number 9. So, okay. Alright, so that's the first page done. Let me take a short break and we will move on to circles. So circles take a majority of this part, so hang tight. Okay, so we're now on to circles, and let's review the parts of a circle. So first and foremost, the radius, this blue line, is a line segment that's from the center of the circle to any point of the circle. So center of the circle to any point of the circle. Next is a diameter. It connects two distinct points while passing through the center and is technically the longest possible chord. Likewise, the chord is just connecting two distinct points, but it doesn't necessarily pass the center. Then a tangent, the pink one over here, is a line, ray, or segment that intersects exactly at one point on the circle. That one point of intersection is called the point of tangency. So this one over here is the point of tangency. And the secant or secant is a line that passes through 2 points, exactly 2 points on the circle. Well, it can't be 3 points unless, yeah, no, it can't be 3 points. It cannot be 3 points. So all radii of a circle are congruent. That's a theorem. Anyway, let's try to solve some stuff using this. So number 15. So, I think I have to use a darker one here. A darker pen so that you can properly see. There we go. 15. Refer to the given diagram. The length of RA is 72 and the length of XC is 54. Find the length of RX. So we know that this RA is 72. So therefore what we can do is just spin it around anywhere on the circle, and it's actually going to result on the same measure. So we have 72 cm here, which means since RE is also it's also a radius, it also means it's 72. Similarly, since XC is a radius and is 54, XEX also, or XE also means 54. So in order to solve for Rx, it actually is simply just 72 plus 54, which equals to 126 cm. There we go. So that's basically it. Okay, next, a more complicated one. Refer to the given diagram. Circle A has a radius of 12, circle B has a radius of 8. Suppose GH is 3. Find the length of EF. So let's analyze the figure here. We have another radius over here, which is 12. So we can say EA is 12. What are we looking for? We're looking for the EF, so everything, this entire line over here. Now we can also say AH is 12 because it's also another radius. So that's another one down. Now we can say, since this is 8 and this is 3, therefore HB is 5. And lastly, since BF is a radius, it's also 8. So by adding 12 plus 12 plus 5 plus 8, we get, so 12 plus 12 plus 5 plus 8 is equal to 37 centimeters. So this is number 16. Okay, number 17. This one is a tricky one, and I'll be honest with you, I'm just gonna cover one example of it because just in case it shows up on the test. So this one is actually almost competition level. So based on the given diagram, we can say this is also x plus 3 because if it's a radius. It's also we can also use Pythagorean theorem to solve for x. So how do we do this? We need to use binomial expansion theorem already. So it's going to be a squared. So in this case, it's x plus 3 squared plus b squared. So x plus 3 squared again is equal to x plus 6 squared. So when you expand this becomes x squared plus 6x plus 9 plus x squared plus 6x plus 9 is equal to x squared plus 12x plus 36. So if we combine like terms, we can say that 2x squared plus 12x plus 18 is equal to x squared plus 12x plus 36. We can start transposition. So if we transposition 36, it becomes negative. So it becomes negative 18. Then transposition x squared, it becomes negative x squared. So it becomes x squared. And then the 12x just cancels each other out. So it's x squared minus 18 is equal to 0. X squared equals 18. X is equal to the square root of 18. X is equal to 3 root 2, which is about 4.24. I don't know why they included this. This is a pretty complicated one. But yeah. Okay, there. Alright, something a little bit easier. Let's try central angles. So central angles is the vertex. The vertex is the center of the circle, and the sides are radii. So in this given diagram, we have AOB is a central angle, while arc AB is the inscribed arc. So remember that the central angle and the the intercepted arc is the same. So measure of angle AOB is congruent to the measure of angle AB. Using the diagram, let's solve for all of these. So measure of MBC. So MBC. So since we're given this is 80, therefore it's also 80 degrees. Arc CD, same logic over here, 130, so therefore this is also 130 degrees. Arc DE, same logic again, 40 degrees, so therefore this one is 40 degrees as well. Alright, then BAE, measure of angle BAE. We know that the sum of everything here is 360. So 130 plus 80 is 210, plus 40 is 250. 360 minus 250 is 110 degrees. Okay. Next, arc BE. So therefore, it's also equal 110 degrees. And then angle BAD. So it's just equal to 110 plus 40. Which is 150 degrees. Then major arc BCD, so it's just equal to 130 plus 80, so 210 degrees. And then arc DB, which is also 150 degrees. So it's pretty simple. Okay. Next one. There are three types of arcs. If it's less than 180 degrees, it's equal to a minor arc. If it's exactly 180 degrees, it's a semicircle. And if it's more than 180 degrees, it's a major arc. So minor arcs will be represented as two letters. So let's say arc AB. But a major arc would probably be labeled as like arc ADB. So with that knowledge, we can also determine the measurement and type of arc. Okay, let's use a bit of theorems here before we begin. We can say that since this is a line, that's the diameter, right? This is equal to 180. So therefore, this one is equal to 60 degrees. And then, we can also say that vertical angle theorem applies to this one and this one. So this is also 50 degrees. And therefore, we can say that 50 plus 50, 100, 160, then 230. So therefore, this one is 130 degrees. Let me clean it up. 130 degrees. So with that knowledge, let's try to solve for the following. So angle ABD. arc ABD. So that's 50 plus 60 plus 70, which is 180 degree, which is a semicircle. Then arc BC, we solved it already, is 60 degrees. Minor arc. Arc AC is 70 70 plus 60, which is 130 degree. Minor arc. Then we got arc AE, which is 50 degrees by the vertical angles theorem, and the same theorem we used to solve the arcs. And lastly, arc BDE. 130 plus 50 plus 60 is 240 degrees. Major arc. So there are also some so that's all for central angles. Is very simple. So the next type of angle that you will commonly come across is called the inscribed angle. So inscribed angles have a different formula for their measurements and their intercepted arcs. So properties of inscribed angles are: vertex is on the circle and the sides are two chords. So given this figure, we can say that angle ACB is an inscribed angle and AB is the intercepted arc. So we can also say that measure of arc AB is equal to the half measure of angle ACB. Now there are a few corollaries that we can use later to solve, or you'll encounter these. You will be encountering these corollaries in proving or in problem solving. So there's 4 of them, but 3 of them are the only ones that have problem solving. So let's go to that one. So first one, we need to find sorry about that, but we need to find corollary 1 first. Corollary 1 states that inscribed angles that intercept the same arc are congruent. So what does that mean? As we could see over here, let's highlight it in green. It's the red angle and blue angle are both intercepted by arc AD. So since they're both intercepting the same arc, we can say that angle DCA is equal to DBA. So therefore, by substituting their values, by substituting their values, we can say that 6x minus 17 is equal to 3x plus 19. Transposition, 6x minus 3x is equal to positive 17 plus 19. 3x is equal to 36. X is equal to 12. And then for the measure of DBA, x is equal to 12. So 3x plus 19 is equal to DBA. Twelve 3 plus 19 is equal to MDBA. So therefore 36 plus 19 is equal to MDBA. 55 is equal to mdBA. So that's the answer for numbers 31 and 32. Okay, next one. Number 33. And corollary 2. Angles that inscribe semicircles are right angles. So given that the inscribed semicircle is equal to 4x plus 76, find the value of x. So this is number 33. So remember that a semicircle is 180 degrees. So we can just say 180 is equal to 4x plus 76. Then once you transposition 76, we get 180 minus 76 is equal to 4x. Simplifying that, we get 104 is equal to 4x. And then once we divide both sides by 4, it's 26 equals x. Okay, next. Corollary 3. The opposite angles in inscribed quadrilaterals are supplementary. So therefore, this angle and this angle is equal to 180. So in order to solve this one, we need to combine the terms. So it's equal to 11x plus 7 plus 3x minus 23 is equal to 180. 14x minus 16 equals 180. 14x is equal to 196. Divide both sides by 14 to get x is equal to 14. Right? Yeah, right. Last corollary. If two arcs of the circle are included between parallel segments, the arcs are congruent. So if this one and this one are parallel, then the ones marked in red are congruent. As simple as that. So going back to our checklist, we have now identified the names and other figures. We've done that a lot. And we also determined the relationship. Okay, tangents. I believe page 3 is about tangents. Okay, tangents. Page 4. Tangents. Is this about tangents? Yes, a few of them. Okay, so short minute break and then I'll be back. Okay, so this one, page 3 is all about angles formed by chords, tangents, and secants, as well as the properties of tangents. So theorem 1, actually this is the only theorem. If a tangent line is on a circle and the line perpendicular to it is the radius drawn at the point of tangency. So it's illustrated here. This is the center. And as you could see, it's going to be a perpendicular line. So given that example, solve for P in number 35. So we know that PSY is 90 degrees, so we can do 90 degrees. And we're also given 42 degrees. Let's call that missing angle X. And that's equal to 180 degrees because triangle's 180 degrees. So we can say 132 degrees plus x degrees is equal to 180 degrees. So by transposition, we can say x is equal to 48 degrees. And that's the answer. Next, okay, this is about a bit of a trickier one. So circle D has a radius of 5 and this figure over here. Find the length of FE. So the thing about this is that since this is a Pythagorean theorem. Yeah, this is wait. I put the Okay, wait. So just save this for now, but wait. I put the stuff on the wrong layer. My bad. Anyway, let's redraw that. So you could screenshot it. So the answer is x is equal to 48 degrees. Okay, we're in the right layer now. Apologies for that. Number 36. So number 36 solution. So we can say that this one is our B, right? We have A, B, and C now. So by Pythagorean theorem, we can say A squared plus B squared is equal to C squared. 5 squared plus B squared is equal to 13 squared. 25 plus B squared is equal to 169. B squared transposition is equal to 144. B is equal to 12. Yeah, and that's our answer. Okay, nice. So there are also two corollaries. Corollary 1, two tangent segments that form a common external point of a circle are congruent. So as you can see over here, they have a common external point, and it actually creates I believe SSS. It could be SSS or SAS congruent postulate. But yeah, we'll prove later. Okay, so then corollary 2, two tangent rays that form a common external point determine an angle that's bisected. So as you could see, if we have 2 points and then we connect a line from the point to the center, that line becomes also a angle bisected. So using those corollaries, we can do this one. So for number 37, so since these two also are equal, therefore plus this common point here, so we can say this is 12. Same logic goes here, 18 and 6, 6. Yeah, 6 was given. 6 was given, by the way. So we can say that this is 18, 24, and 30. So it becomes, let's do 18 plus 18 plus 12 plus 12 plus 6 plus 6 is equal to 36 plus 24 plus 12, that is 72 cm. So yep, and then we can see that the ratio is 18 is to 24 is to 30, which means it's a 3, 4, 5 triangle, which means number 38, it's a, so 3 is to 4 is to 5 is equal to, is equal to 18 is to 24 is to 30. So right triangle. My screen got a bit dimmer, and apologies for the ad. Okay. Next one is, this is where the point where you have to memorize a bit of formulas. So yeah, this is angles formed by chords, tangents, and secants. We're now in cycle 3. So let's start with corollary 1. The measure of an angle formed by a tangent and a chord or secant drawn to the point of tangency is equal to 1/2 of the intercepted arc. To put things simply, basically if you see a figure like this, or this, you can basically treat it as a inscribed angle. I'll show you here. So number 39. know that 160 degrees is equal to 1/2. Oh, sorry. Sorry, it should be 2. It should be 2. 2 m p and q, because remember, this is double of p. Oh, sorry. No, wait. So we're solving the wrong thing. Oh no. M, P, and Q first. M, P, and Q. So we have 160 here, which means to complete the circle is equal to 360 minus 160, which means M, P, and Q is equal to 200. That's the answer. Okay, next, number 40. Measure of P and Q. There, MPQ, sorry. Angle MPQ. So MPQ. Okay. So we have an inscribed angle of arc of 200. So therefore, 1/2 200. So MPQ is equal to 100. Okay, so that's equal to 100. Basically, it's just the inscribed angle theorem. Next one is 41. We have MQPR. Measure of QPR, angle QPR. So in this case, it's equal to 1/2. Oh, sorry. Yeah. Oh, yeah. 1/2 of 160. QPR is equal to 180 degrees because of the theorem. You can also say, since this is 100 degrees and this is a straight line, you can also say this is 80 degrees. So that's also an acceptable solution. Okay. Next one. Okay, finally. Looks like my screen is going weird. I'm gonna unplug. It's at 96%. Okay. So, theorem number 2. The measure of an angle formed by two chords that intersects is equal to 1/2 the sum of the arcs intercepted by the angle and its vertical angle. So basically, it's like this one plus this one is equal to 1/2 of this one. So we can solve that. Let's try to solve arc CD given that arc EB is equal to 60 degrees and CFA, angle CFA is equal to 80 degrees. So MC, we can say that number 42, measure of arc CD plus 80, plus 60 over 2 is equal to 80. Let's multiply both sides by 2. So we cancel out the 2. So this is equal to 160. And this is MCD plus 60 equals 160. MCD is equal to 100 by transposition. So there we go. Okay, let's try to solve now with x involved. So using the same formula, number 43, we have, we can say 6x plus 4x plus 10 over 2 is equal to 60. 10x plus 10 over 2 equals 60. Okay. Yeah, okay. then double it to cancel the 2 at the bottom. So 10x plus 10 is equal to 120, and 10x is equal to 110, x is equal to 11. So that is our answer. Okay, so now go back to the checklist layer. We use the properties of tangents to solve problems, and we solved angles formed by chords, tangents, and secants. Actually, that's part 2. There's still a part 2 of that, but I'll count it already. So part 2 will involve near and far arcs. That's still under the what do you call this? It's still under the angles formed, and then we have segment lengths over here, and then we have proving, and then we got distance and midpoint formula. I'd say we're about 50% done by the video by now. So I'll take a break and I'll see you guys then. Okay, so let's continue. So for near and far arcs, we got far minus near over 2. So there's 2 tangents, 1 tangent, 1 secant, and 2 secants. So these are the far and nears respectively. Just subtract them and divide the result by 2 to find the angle x. Let's apply that. So find angle B in this scenario. We got for number 44, we have our far arc is 130 and our near arc is 40 over 2. So therefore, our angle D is equal to 2 is equal to 90 over 2, or just 45 degrees. Next, what if one of the arcs are missing? So let's try to solve that, shall we? So we have 200, that's our far, minus x is our near, over 2 is equal to 60. Let's multiply both sides by 2 to cancel out the denominator. So it's 200 minus x is equal to 120. So therefore, 200 minus 120 is equal to x. 80 is equal to x. And that is going to be our answer. Okay, nice. Next, segment lengths. So for this one is the perpendicular bisector of a chord. I didn't even see it on the test, and seeing as I don't physically see as this being on the test, but I just put it here for reference purposes. So basically, we have perpendicular bisector, so as you can see there. So therefore, this one and this one are congruent. Yeah, it's quite weird. Anyway, for segment lengths, we have 3 theorems. So as you can see, if we have 2 secants, we can say EA, this one, EA times EB is equal to EC times ED. Oh, wait. Yeah. And this is also 2 secants, but if we have something like this structure, we can say EA times EB is equal to ED times EC. And lastly, we got EC times ED is equal to EA squared. So those are the 3 formulas you need to know, because it's not given on the test, sadly. That's why I don't have the formula box over here. The formula box would be here, but we're not given them, so we need to memorize them. How sad. Anyway, let's try to find x for this one. So like I said, this one times this one is equal to this one times this one. So we can say that on number 46, we are going to do 8 times x is equal to 16 times 12. So let's get out our calculators. 8x is equal to 192 And x should be equal to 20. Is that 24? Let me check. Yeah, 24. And that's our answer for the 46. Now number 47, this one involves what do you call this? Variable. So but same logic. So we can say number 40, ooh, that's not the right color. Number 47 is equal to 3 times 2x minus 10 is equal to 2 times x plus 27. So 6x minus 30 is equal to 2x plus 54. When we transposition that, is equal to 6x minus 2x is equal to 30 plus 54. 4x is equal to 84. X is equal to 21. And that's the answer. Next, number 48. So we're using a different one. This one's gonna be a little bit tricky because but it still doesn't involve the quadratics, so it's okay. So we can say that by this one times this one is equal to this one times this one. We can equate 9 times 9 plus 26 is equal to 7 times 7 plus x. That's equal to 9 times 35 is equal to 49 plus 7x. And then this is equal to 315 is equal to 49 plus 7x. Then transposition 49 is 266 is equal to 7x. 38 is equal to x. And that's the answer. Okay, find x, number 49. So by this one is equal to this one. No, sorry. This one times this one is equal to this one squared. We can say that we can equate it to 8. We can equate this one to 8 times 8 plus x is equal to 16 squared, which is 256. Multiply this one, it becomes 64 plus 8x is equal to 256. 8x is equal to 192. And x is equal to 24. And that is our answer. Okay, next one, we do proving. I just need to recheck the answer key for this one because this one's quite strange. Okay, proving time. I only was able to find one example, and finding the answer key for this one was tough. So this is just my idea. If you have another idea, go ahead. So from what I can infer over here, the given statement that we can use is the second one here. So AB is congruent to CD. Arc. That's given over here. Okay, so since we're using 1/2 over here, I inferred that this one would be inscribed arc theorem. Inscribed arc theorem. Because as you can see, we're defining the measures of angles by what arc they intercept. So this is inscribed arc theorem. So what I assume here happened here, now that they're both AB, I think we can say substitution. Substitution. Because all of these are the same, so we can substitute them. Then therefore, because we now only have 3, A equals B, B equals C, therefore A equals C. So, sorry, A equals B, A equals C, then B equals C. So we can say M of ACB is equal to M of DBC, if I'm not mistaken. Then these are definition of congruent angles. Okay, then this is another given statement, so given. So angles are congruent. So what I inferred from here is that BAC, angle BAC, is congruent to angle CDB. Because they both intercept arc CB. And then we can say BC is also congruent to BC because it's congruent to itself. Now I don't know what to put for the last part because it's clear we solved 2 angles, right? So we have MACB, let's highlight that. ACB, DBC. Oh, sorry, ACB, this one, and DBC, this one. And then we have BAC, BAC over here, and then CDB, which to my knowledge should be, and then we got, what's this? BC is equal to BC. Okay, it's quite weird, but if I'm not mistaken, that's AAS, right? Yeah, AAS. It's very weird. They didn't give us the answer key for this. But I guess that's what we have to work with. So yeah, that took me a while. I'll go back with distance and midpoint formula. These ones are just quick. Okay, distance and midpoint formula. This is going to be a very short one. Actually, I think I'll just record to the end now. So, distance formula is defined by this one, and you can just substitute the values in to get the answer. So take for example number 59. If you put this one in the calculator, the square root of, so x sub 2, which is this one, 3 minus 6, 3 minus 9 squared plus 5 minus 13 squared, that's equal to the distance. So try to put this in your calculator. So this is equal to just the square root of -6 squared plus -8 squared. And this is just equal to 10. So the answer for this one is 10. Same thing with number 60. It's very repetitive actually. There's not much we can do here other than just practice doing it. But then again, it's just substituting numbers, and in fact, once you get the hang of it, you can actually do it almost mentally. So let's do the same logic again. Negative 4, so that's x sub 2 minus x sub 1 minus 4 squared is equal, and then plus negative 1 minus 5 squared. So that's just equal to, let's put that in our calculator, guys. It's recommended that you have a multi-line calculator for this, but this is also equal to 10. Yeah. You can cross-check it using the Cartesian plane later. Now, how about this one? So actually, I actually prefer to do this visually. So let's try to imagine it. So the distance between x4 and 2,9 is 13 units. Find x. So we can actually form two triangles here. So let's start what we know. We know this is x4, right? And our y coordinate is 5 units above that. 5 units because this is 2,9. We need to find two solutions here, because either way this one will equal 13. So this triangle will equal 13, and this triangle would also equal 13. So how do we do that? So first, we know that the difference between 4 and 9 is 5. So this is 5. And we know that another side of the triangle that's formed is 13, like this. 13. So we just need to find this one. So 13 squared minus 5 squared is 12. So we need to find the two values of x that lie... Sorry, wait. How do I draw this? Let me adjust it real quick. So this is x sub 4. So we need to find the two values of x that will give us a value of 12. So it's like this. Oh wait. It's x, right? Okay. Well, so obviously what we can do is go here 12 units, and hold on. Okay, sorry. I know now what went wrong. I illustrated it wrong. Yeah, although we know that this is 5, so let's just say, so we know from this point we need to either up by 12. So what the actual solution is, change this by 12 or negative 12. So it's either actually x is equal to negative 10 or 14. So it's basically 2 plus minus 12. Okay, my apologies for that. It's gonna be this one. Okay, midpoint formula is pretty simple as well. You just have to substitute again. And there's no square roots to mess us up. It's just addition. So let's try this one. Number 62. We have negative 7 plus 14 over 2 and negative 12 plus negative 4, 2. So that equals to, let's see that one. I believe that's 3.5 and 3.5 and 4. So let me just check. I'll check our answer key to make sure. This is the part where I'm starting to get a little iffy. Okay, yep, it's correct. It's correct. All right, let's go to the next one. Number 63. Same thing here, but you can actually use a oh no, this is midpoint, sorry. So what this one, if it's 0 0, just half this one. So it's very simple. So half of 20 is 10, and half of negative 11 is negative 5.5. And that's the answer. So just one half the value. Okay, that's actually midpoint is midpoint formula is just substitution. So this one, you'll also encounter this one. If the midpoint is 16 negative 24 and the other endpoint is at 13 negative 12, find the first endpoint. So it's actually helpful that you visualize this one. So we have 16 negative 24, right? And then we have another point at 30 negative 12. So we went, this is our x coordinate went up and our y coordinate also went up. So we're going here, 30 negative 12, right? So that means to complete the line, we need to find this segment over here. Because usually, sometimes you end up finding this segment. Now, this becomes the midpoint, so it's wrong. So we need to find this segment over here. And what I usually like to do is just to find like the difference. So imagine this one, right? So I can see that from here to here, it decreased by 14. So I can say that the first one is 2. And then second one here, it decreased by 12. So I can say another decrease of 12 over here. So it's negative 36. And that's going to be our answer over there. So this is our answer for number 64. Okay, one last page. Let's check off the objectives that we were able to accomplish. So this is the solve for lengths of segments. Yes. Proves, we already proved some theorems, arcs, central angles, and everything and whatnot. What's this? Applies the distance and midpoint formula. Okay, now it's just equations of circles. Honestly, look, at this point, this is pretty much... Okay, let me pull up a Cartesian plane real quick. Okay, so this last one, I just put a lot of items because it's easy, okay? It's easy to spam it. It's easy to... It's just easy. It's generally easy to, what do you call this? Do it repetitively. So the equations of circles, we have two of them. Radius and general form. So for radius form, it tells us the radius as well as the center of the circle. You can get the center of the circle. And then for the general form, it just, well, makes one side 0. So let me try to explain here. So let's use number 65 as an example, okay? I'm not even going to do the green text. I'm just going to put them right here. So let's use a bit of logic here. So we know the centers is 0, 0. In fact, the center is defined by this h and k over here. If it's 0, then it's considered negligible. Therefore, you can just actually put if the center's at 0, 0, you can just put x squared plus y squared. For all of these, you can put x squared plus y squared immediately. Because all of the origins are at 0, and you can just omit the 0. Like x minus 0 squared is still just x squared. Y minus 0 squared is also just y squared. So the only thing you need to do is the r squared. So what's this one? 5 squared. So 25. R squared, 3 squared, 9. Square root of 2 squared. Just remove the square root. 2. Simple. Now what if we're given a radius and a center? Okay, it's a bit more complicated, so I'll slow down on number 68. So first and foremost, we have the center as 2 and 3. So remember, for these ones in the paragraph equated to 0. Parentheses equated to 0. So we have x equals 2. So to equate it to 0, we must put x minus 2, so that when we put it inside, it still results in 0. And then we got plus y squared over there. So y minus 3, because it's the inverse, squared. And then do the same thing we did a while ago, just square the 36. So that's 36, right? There we go. And then you can just repeat that. Once again, let's try again, okay? Negative 2. Find the inverse of negative 2. It's just positive 2. Squared. Plus y, that our center is 4. Y minus 4. Squared. Equals 9 squared. 81. Keep repeating it again. Okay? 3. Inverse of 3, negative 3. X minus 3. Squared. Then plus y minus 5. The opposite of negative 5 is positive 5. Plus 5. Squared. Again, it's very simple once you get the hang of it. 4 squared. 16. Last one. Negative 1. Flip it again. X plus 1. Squared. And then negative 6. That's positive 6. So y plus 6. Squared. 7 squared. 49. It's that simple. So these numbers, they're very simple once you know them. Next. General form time. So let's take this a bit slower and let's do a solution this time. We have a lot of space anyway. Okay, I'll pull up another Cartesian plane for later. Okay, so first and foremost, so x, let's do 70. What's this? 72. Okay, we put x minus 7 times x minus 7 is just x squared. Sorry, x minus 7 squared plus y minus 1 squared. So this is just equal to x squared. Then you multiply this by 2 to get the 14x. Then 49. That's just the binomial expansion theorem. Then y squared minus 2y, because double this and then add a y. And then plus 1 is equal to 1. Okay? We can transposition the negative one, so we can cancel this one out. So it just becomes x squared plus y squared. And then we got minus 14x minus 2y plus, I believe that's 49, is equal to 0. Let's double check that to make sure it's correct. General form. Okay. And that is correct. That's correct. So this is the answer of 72. Try not to obstruct the answer. There we go. Number 73. Same process again. Let's use the binomial expansion theorem. Is x minus 2 squared plus y plus 3 squared is equal to 121. So this becomes x squared minus 4x plus 4 by binomial expansion theorem, plus y squared, and then 3 times 2, 6y, plus 9 is equal to 121. So this becomes 4 plus 9, 13. 13 minus 121 is equal to negative 108. So this one becomes negative 108 equals 0. Then we just put everything else in order. X squared plus y squared plus 6y, plus minus 4x plus 6y minus 108 equals 0. And that's the answer. So, last one, number 74. Okay. Alright, hold on. Okay, there we go. So, last one, we got x plus 9 squared. X plus 9 squared plus y plus 5 squared is equal to 2. So binomial expansion, we get x squared, double 9, 18, that's your x, then square 9, 81, plus y squared, double 5, 10 squared, 10y, 5 squared plus 25 equals 2. Combine the constants. So to get the constants, we need to so combine the constants. 81 plus 25 is 106 minus 2, so it's 104. It's positive 104. Then rearrange in order. X squared plus y squared plus 18x plus 10y plus 104 is equal to 0. And that's the answer. Okay, now it's time for graphs, and I will just use different colors for this one. So let's start with number 75. We got I'm gonna pull up an extra Cartesian plane. Here. So I have an additional Cartesian plane. Let's use number 75 as the blue one. So we have, remember that this one is just the point of origin. If it's x squared plus y squared equals r squared. So r squared is 9, so r is equal to 3. So we just want to draw a circle that's 3 points from the radius. So 1, 2, 3. Just like that. So that's our number 75. For number 76, let's use orange. So same thing again, r squared is equal to 36, r should equal to 6. So we need to go 6 units away from the center. 1, 2, 3, 4, 5, 6. Like this. Okay. It's not too equal, unfortunately, but I mean, it's the best we got. Now let's do... Oops. Now let's do 77. This one is a little bit different because we now need to find the center. So remember, the center, you need to equate it to 0. So x minus 2 equals 0. So your x is 2. And then since it's y minus 3, your y is 3. So 1, 2, 3. So that's our center. And our r squared is 4. Which means r is equal to 2. So from this point, we draw 2 units. 1, 2. Just like that. Oh, I'm so sorry. You can't see that properly. I hope you still can, though. I'll use a different color this time. Yellow. And then lastly, for the fourth one, let's use purple. Okay, So we got x plus 4, so x equals negative 4, so equals here. Then y is negative 1, so y is 1, so it's here. Then we want r squared is 25, so our radius should be 5. So what we do is 1, 2, 3, oh, I zoomed in too much. 1, 2, 3, 4, 5. Just like that. Okay, just like that. Perfect. So how can we apply this, you may ask? Well, signal towers is the best example, I guess. So for numbers 79 to 81, let's write each equation. So first and foremost, for the bridge tower, let's do red. Red for the bridge tower. Center is at 3, 4. So x minus 3 squared. And then plus y minus 4 squared. Because remember, inverse. And since the radius is 9 kilometers, we square 9 to get 81. Okay, then for the universal tower, we got negative 1 and 1, so it's going to be x plus 1 and plus y minus 1 squared. Squared both this one, and it has a radius of 4 kilometers, so 4 squared is 16. And lastly, the here tower, let's use green, is at 12, negative 3, and I think that is out of bounds. Yep, I did not graph that. Uh-oh. Okay, we'll make it work. We'll make it... Okay. Okay, let's just imagine it, I guess. Okay, because clearly... Okay, I'll get a bigger graphing plane later. No, I think it works. Yeah, we can just do that. Okay, finish this one. So 12 x minus 12 squared plus negative 3, so y plus 3 squared is equal to 6 kilometers, so 36. Okay, now let's graph them. So I might have to overlay this one. So no, let's use 50% transparency. Okay, so we need to find the center first. 3 and 4. So 1, 2, 3. So it's over here. Then 1, 2, 3, 4. So over here. So the center is over here and it's 81. So hold on. So it's gonna be 1, 2, 3, 4, 5, 6, 8, 9. Like that. So it goes out of bounds. How unfortunate. And then for the blue one, it's gonna be 1, negative 1, 1. So negative 1, but positive 1. And it has a radius of 4. So it's here. So it's 1, 2, 3, 4. Like here. Oh, they're intersecting. Okay, interesting. So sometimes you get very weird ones, but yeah. And then lastly, negative 12, 3 with a radius of 36. That's not gonna fit here. So it's 12, negative 3, so 12, and then negative 3 for the y, so it should be here. And let's use the green color, and it's 6. Oh no, oh no. Okay. 1, 2, 3, 4, 5, 6. Yeah, due to budget cuts, we are not able to graph the entire thing. But yeah, it looks roughly like this on the answer key. So that's how we graph it. And then let's now find the points. So we need 15 ones. So let's turn off our tool. So 12, 13, 14, 15, and then 1. So that's clearly still in the green zone. That's 15.1. Then 2.8. 2.8, so it's 1.2. Then here. And then for 1.3, 1, and then 3. Okay, so now I will put the colors. So this one, so 2.8 is by the red tower, so it's the bright tower. So bright tower covered. For the 1 positive 3, it's gonna be red covered and blue covered. And for 15.1, it's just gonna be green covered. And that's it. That's your math ETA done. It took me around, I think, an hour and a half to cover everything, right? I think around an hour and a half. So we write the center, radius, form, and general form of a circle. We determine the center of radius given its equation and vice versa. And we graphed a circle on the coordinate plane. And that's it, guys. That's grade 10 math for you. Okay. So future batches, feel free to refer to this one. And once again, thank you all so much. It's been a rough year. So much stuff to do, but I still have time to do this. So thank you all so much for watching. Take care of yourselves, and I'll see you guys next time. Bye. Okay, so do I get Ado merch for this? Yeah. I'll just finish the recording. Oh. Oh. Wait. What? Did I win something? Yeah, hold on. Ado shop. I said it's hold on. I got a poster. I'll send some money. Hold on. Oh, dang it. It's all sold out.